Okay, let's look at how to do questions 1A and 1B from the Thermochemistry Phase Change Practice 2018 worksheet. So, question 1A to start off with, it says sketch the heating curve when 4.5 grams of ice at -5 is heated to liquid water at 75. Okay, so you need to learn how to make one of these, and it goes like this. So you start, I call it kind of an up, over, like a flat line, up, over, up. So I just kind of refer to it to an up, over, up, over, up. All right. Now, if you know, this is for ice, so this point right here represents the melting point or the freezing point, and that's 0 degrees Celsius, and it's supposed to be a straight line across, and that's also 0 degrees Celsius. And this point up here represents the boiling point of water, which is 100 degrees Celsius, and this also would be 100 degrees Celsius. So when you heat water, we call when something like here is a solid, this is when water is a liquid, and up here is when it's a gas. So when we call a solid to a liquid, we call that melting, and we call from a liquid to a gas, we call that vaporization. All right. So anyway, on this graph, we're starting off at -5, so I'm just going to mark that right there at -5 degrees Celsius. And we're going to 75, so I'm just going to put it up here somewhere, 75 degrees Celsius. Now, what you're going to want to do a question like 1B is you're going to want to divide this graph into segments. So from 1B, it's the same problem. So calculate the energy required to change 4.5 grams of ice at -5 degrees Celsius to liquid water at 75 degrees Celsius. So you're going to want to divide it up into segments. Like this is the first segment. You're going to calculate the energy needed to warm the ice up to the melting point. Segment number 2 is you're going to calculate how much energy it takes to melt the ice. And segment number 3 is you're going to calculate how much it takes to warm the liquid water up to 75 degrees Celsius. So there are 3 steps, 1, 2, 3. So I'm going to take them in individual steps. Okay, so step number 1, whenever the graph is changing temperature, it's going from -5 to 0. Whenever it's changing, you're going to use the equation Q equals mc delta T. Then you're going to plug in the numbers. Q equals, because Q is the amount of energy it's going to take. So the mass, and the mass is 4.5 grams. You're going to take that times the specific heat of ice. Now, the specific heat of ice is different from liquid water. The specific heat that we're using is for ice is 2.09 joules per gram degrees Celsius. So this is the specific heat of ice. Okay? So that's going to be 2.09 joules per gram degrees Celsius. And we're going to take it times the temperature change. Remember, it's always final minus initial. So it's 0 is the final because we're only doing this segment. So it's like 0 minus a -5. So 0 minus a -5, which basically just equals 5 because 2 negatives make a positive. So then what I'm going to do is I'm going to take 4.5 times 2.09 times 5 degrees Celsius. And I end up getting 47 joules. For the purpose of this problem, though, we need to work in kilojoules. And the conversion from joules to kilojoules is that in 1 kilojoule, there's 1,000 joules. Now, instead of doing this conversion factor every time, you should just remember to change a joule to a kilojoule, you're moving the decimal 3 spots. So it ends up being 0.047 kilojoules. That's how much it takes to go from -5 to 0. All right, now we have to do step number 2. Step number 2 is the energy required to change from ice at -0 to liquid water at 0. Whenever you have a flat spot of the graph, you're going to set up a picket fence. And the thing is, you have to be in moles. So you're going to use this 4.5 grams of ice, which is water basically, all right, that's just frozen, you got to change it to moles. So 1 mole water, remember, is 18 grams of water. Now, you're going to use this thing called the heat of fusion. And you'll see it will look like a delta H with a little FUS. So delta H of fusion for water happens to be 6.01 kilojoules per mole. That means for every 1 mole of ice that you want to melt, it needs to absorb 6.01 kilojoules. So now we're going to keep in mind our principle of diagonality. So we got 1 mole of water here. So here's what this says. For every 1 mole of water we want to melt, it needs to absorb 6.01 kilojoules. And then you're going to take 4.5 times 6.01 divided by 18, and that equals 1.5 kilojoules. Now the reason that I changed part number 1 in kilojoules is because they want this answer in kilojoules usually, so we're going to add together at the end part 1, part 2, and part 3. That's why it was changed to kilojoules. Okay, now part 3. Part 3, the graph is slanted. That means the temperature is changing during this section. Wherever the temperature is changing, you're going to use a Q equals MC delta T. All right, so anyway, we're going to take Q equals M. That's the mass of our water, which again is 4.5 grams. Okay, we're going to take that times the specific heat. But now we have the specific heat of water. Remember that number is 4.18. We've been using that number. That's for liquid water. Grams degrees Celsius, joules per gram degrees Celsius. Then we're going to take it times the temperature change. The temperature change is the final temperature, which in this case we're only going to 75 because that's what the problem tells us to go to. Okay, so it's going to be 75 minus 0, which is 75. Because we're only going from here to here, so that's 75. A lot of times you don't have to write out 75 minus 0, you can just put 75 there. But anyway, so Q equals 4.5 times 4.18 times 75. You end up getting 1,411 joules, but I'm going to change that to kilojoules by moving the decimal 1, 2, 3 spots. So that's going to equal roughly about 1.4 kilojoules. Now, when I get it all said and done, I just have to add my answers from 1, 2, and 3 together. So I'm going to take 0.047 kilojoules plus 1.5 kilojoules and 1.4 kilojoules. I'm going to add all those together. And when I do that, I get 2.947, and I'm going to round my answer off to the nearest tenth. So that's going to equal about 2.9 kilojoules. Okay, 2.9 kilojoules is how much it takes to go from -5, ice at -5, to liquid water at 75. All right? So it really helps to do them in steps. Step 1, step 2, step 3. Whenever the graph is slanted, you're going to do a Q equals MC delta T. Whenever the graph is flat, you're going to use a picket fence using what's, in this case, it's called the heat of fusion, which is 6.01 kilojoules per mole for water. Now you don't have to memorize these numbers. They will be given to you on any test. All right, so that's the end of that problem right there. After you look these over and so see if you can do 1A and 1B, you need to try to do 1C on your own and then check your work on the answer key that's provided to see if you did 1C. If you need to pause this video and go back and rewatch it, well, that's what you're going to have to do to understand this. Okay? That's it.